Welcome to the M-Cube seminar. Welcome to the M-Cube seminar. This week, we're happy to have Julie Demuth. Julie has been at NCAR since 2005 and at M-Cube since 2013. Her background is in both physical and social science. She has a BS, MS in atmospheric science and a PhD in communications with a focus on risk. Julie's research concerns hazardous weather risk communication, risk perceptions, and decision-making, including how these intersect with predictability and prediction I can't speak over. Jeez. Go have another cookie. Okay. Julie has been involved in developing multiple national interdisciplinary research agendas and capacity building efforts, including by the National Academies and by the NOAA Science Advisory Board. Her love for weather and its effects stems from when 7 tornadoes hit Grand Island, Nebraska on June 3rd, 1980, where her family lived at the time. She was the 2023 AMS Walter Roberts Lecturer, and for her groundbreaking interdisciplinary work to improve hazardous weather risk communication, dedicated work promoting the exchange of knowledge across the meteorology and social sciences community. And for those of you who are not at that lecture, including me, I'm happy to report that this lecture is going to be a version of the Walter R. Roberts lecture. So today the talk is on dynamic risks and risk perception using longitudinal panel surveys to capture perishable social science data during hurricanes. Julie.
Okay. So nice to see everyone. Thank you. And Morris already asked me why we aren't doing latitudinal panel surveys, so we will touch on this a little bit. Is that clock accurate or is it fast? Just so I know. It's accurate. Okay. So it occurred to me that the only other 2 times that I've given an M-Cube seminar were for a job position, right? Like to go up for a PS3 or something like that. So this is the first time I've actually just been here just to share the exciting science, and it's really fun. So thank you, Rich, for the nudge to do this. I really appreciate it. And even though I'm presenting this, I feel very strongly that this work that I'm talking about is very much a product of this amazing team of people who I have reflected here. So Rebecca Morris, of course, who's also in M-Cubed. Gabrielle Wong-Perotti is a professor at Stanford. She's also been doing longitudinal stuff for hurricanes, but kind of interannually. None of this work that I'm presenting up here would be possible without Andrea Schumacher and her incredible expertise and diligence with helping with so much of the data curation and analysis. Has really been an incredible partner with thinking through the longitudinal data analysis alongside Hugh Walpole. Natalie Herbert is also at Stanford. And then Josh Allen and Dakota Smith have been so invaluable when we have been making decisions about fielding our surveys for these real-world hurricanes, which you'll understand more in a second. And then all of this wouldn't be possible without our incredible NOAA team, not just because they helped fund this, but because they have really been partners along the line. Folks at OAR headquarters, Weather Service headquarters, but also AOML and the National Hurricane Center, Mike Brennan and Robbie Berg, again, for helping us think through this. So really just a shout out to everybody on this slide. So here are the goals today. I really want to talk about this framework that we are developing for really investigating risk perceptions and behaviors as dynamic. And what if we field these kind of event-based, really rapidly deployed, real-time longitudinal surveys affords us for collecting what we call perishable social science observations. And I'll explain what I mean by that in just a second. So that's valuable in and of itself, but becomes even more so when we think about integrating this with meteorological data, and it makes it all the more powerful. So I'm gonna just talk about ways that we have been doing this in the hurricane context, and then share a vision for hopefully growing this kind of work along these lines. So I'm sure I don't, for this crew, have to sell how dynamic weather phenomena like hurricanes are and how dynamic the risks that they pose are. This is obviously what we all really are interested in and study. But I'm just kind of crudely representing this here for Hurricane Ian by looking at the cone of uncertainty, even though we know it's imperfect and only representing a piece of the actual threat, but coupling that with the risk messages. So we can see how the track maybe has shifted, how over time as this threat evolved, there were differences in what the sustained winds were going to be, where those high winds were going to happen, storm surge, inland rainfall, flooding, et cetera. And of course, because we know that these weather hazards are dynamic, we care about collecting dynamic observations and a lot of observational data. So we all, I don't, again, have to sell this point, recognize how observations are fundamental to our science, right? It helps us characterize what's going on, maybe look for correlations or associations, and then ideally start to understand theoretically what's going on, understand what are those processes at play, what causes what, under what conditions, and also look at changes over time. And we are really lucky in the weather community that we have a tremendous observing system. So we have radar, we have surface observing systems, we have buoys, we have satellites, we have so much data, right? And we recognize that it's important to collect data across a lot of different variables, maybe from multiple instruments. If we don't just have one satellite, we have multiple satellites, right? Geostationary polar orbiter and multiples of those. We do this at high spatial and temporal resolutions, and we do this pretty regularly, right? As much as we can. And then in addition to that regular data collection, we augment this. When there's a critical event, we will change the radar volume coverage pattern, right? So we can see the storm differently. Or we'll launch extra weather balloons. Or we'll fly a hurricane hunter into a hurricane. And let me see if I can get this going. Oh, I'm not sure that's gonna work. Hold on. Oh, shoot. Let me turn this off. Turn my laser pointer off and get that. Oh yeah, there we go. I feel like we have to show this. Or maybe, say for Hurricane Michael, we'll task 2 satellite mesosectors so that we can get 30-second imagery of this storm around the time that it's rapidly intensifying and approaching landfall. Again, so that we can see what those processes are. So we do all of that because we understand, again, that weather hazards are dynamic and the risks that they pose are dynamic. Well, it's reasonable then to think that when we have these dynamic weather risks, that people are dynamically accessing information about them, perceiving risks, and responding to them. But interestingly, we don't really know. And the reason we don't know is because we don't have commensurate dynamic observational data of the human system. We just don't have this kind of information. So we might have what we might call these research questions that approach this from a dynamic perspective, wanting to know what kind of tropical cyclone risk information are people getting? How are they perceiving those risks? How are they responding as the actual TC risks are evolving? But the fact of the matter is this question sort of has this dynamic frame, but most of the social science data that we've collected is very static. So there's a real mismatch here, right? And most of that data, most of that research gets conducted like after the event or with hypothetical scenarios. A lot of it is what we call cross-sectional, meaning we're just collecting data at one point in time. And even if we're trying to gather data about how people are managing these evolving risks, we do this either by collecting retrospective interviews where we talk to people afterward, ask them to think about and tell us what happened at different points in time, but of course there's flaws with doing that, or we will use simulations. But what we really need is to study these real-world tropical cyclones and the risks that they're posing in near real time as they are evolving. And the reason I'm highlighting this in near real time, this is what points to the idea of these data that we're collecting being what we call perishable, meaning that they are highly transient or ephemeral, and that if you're collecting them later on, you might be subject to memory recall issues, or people rationalizing their behaviors based on what happened, or talking with other people and having that shape what they think actually happened or what they were thinking at the moment in time. So this is why if you're not collecting this in the moment, you're actually getting less quality data or data that are maybe less valid, right? So this is what is called perishable data. So all of this really points us toward this need for longitudinal studies, right? And these are more common in other fields like health, communication, education. They have been called for in the field of risk analysis, in particular with this idea that we want to understand risk perceptions and when and why they're changing. So is it because people are getting new information, or maybe they're engaging in some mitigated behavior and their risk perceptions go down? I want to give a shout out to Chris, who's one of the postdocs working with me, that he's actually done some work in this arena before he fell in love with weather. He was doing this in the arena of Zika, just so you can see this is going on in other kind of domains. Bringing it back to weather, there is very little. Yeah, Rich.
So just a brief parenthesis, what is meant by a longitudinal study?
I'm going to get to that.
Oh, okay.
Yep. Good question, right? There are different kinds of longitudinal studies. I will talk in a second about what we mean. So basically, it is just getting repeated measures, right? But there are different ways of doing that. So again, coming back to weather, there is very limited longitudinal work kind of in this domain for tropical cyclones in near real time, or any hazard, really, in near real time. Bob Meyer, who is at Wharton, he came here to visit a few years ago. He did what are called trend studies. So this is one kind of longitudinal study where they were doing repeated surveys with people by phone as Hurricanes Isaac and Sandy were making landfall, but they were different people every time. So that is disadvantage. The disadvantage of that is then you can't track what a given person is doing, but you're hoping that if you're randomly sampling that you're getting kind of, approximately the same people. But so it's helpful, but it's just not the same as following the same people over time. We tried to follow the same people over time using Twitter by collecting their narratives. So all of their tweets when Sandy was making landfall, so people who were residing in areas that were under a mandatory evacuation order, just so that we could see what were people thinking, what were they doing. But all of you, I don't even think you have to study Twitter to know the shortcomings of Twitter. There are challenges, not the least of which is that you're just getting what people want to share. So you can't systematically have something you want to measure over and over and over again. There are a lot of challenges with doing longitudinal studies, though, especially when we're thinking about it in this even more refined kind of way where we want to study a given event during its predictive phase. And I know there's a lot of text here, but I really wanted to articulate all of these challenges because this was a key thing that our research team had to identify and overcome so that we could do this research. So when you're thinking about trying to collect multiple measures or repeated measures from people as a hurricane is threatening, you have this issue of lead time, right? Can you identify a risk with sufficient lead time so that we can collect multiple surveys when the hurricane is actually threatening, so before it makes landfall, because that's the time frame we're interested in. How do we identify that target population that we want to sample from? So especially given these predictive uncertainties, there are challenges with, can we get people to respond to repeated surveys over the course of only a few days? You're inevitably going to lose people, what we call attrition, when you go from wave to wave. And then there are these two kind of interconnected points that are really contingent on these time constraints of trying to do this over the course of just a few days. One is, how long can we field the survey for? I'm guessing, even if you think about the NCAR surveys, the culture surveys we do, they're in the field for maybe a week or two, right? Well, we don't have the luxury of doing that when we have a hurricane. So what is the time frame that we could field a survey over? And then we have to have enough of an interval in between so that if there are changes that they can occur and that we can detect that. All of this, of course, kind of is underpinned by these issues of the limitations of TC predictability and prediction capabilities that we just have to manage when we're trying to make these decisions at these multi-day lead times, right? And then last but not least, given that what we were doing was a proof of concept, we had to try to do this at a reasonable cost level, not with millions and millions of dollars, although my hope, as you'll see from the vision, is that eventually we will get to thinking about those amounts of money. So because this is what we had to do as part of our research project, one thing I'll just quickly note is this was part of our deliverable to NOAA, is that we would identify again and overcome all of these barriers or all these challenges and provide basically a methodological roadmap to the community with findings and recommendations for how to do this differently or better in the future. And I can certainly talk about some of that more if folks are interested. But just to go directly to your question, Rich, this is the kind of longitudinal study that we're talking about here, what we call a longitudinal panel survey, meaning we are surveying the same people multiple times so that we can actually track whether, when, and how they change, okay? So this is what we wanted to do, is to conduct these surveys during a real world tropical cyclone so that we can investigate whether, when, and how people are getting different information, their risk perceptions are changing, their responses are changing as the actual TC risks are increasing or decreasing in different areas. And again, hopefully I've made the case for this, that it hasn't been done before. So part of the other piece of this was developing this methodology. So this was our approach that we originally developed and for the most part adhered to, although you'll see there were a few different differences from this, that we worked with a survey company called YouGov and said that we would do a web-based English-only survey to begin with members from their survey panel, okay? So we aren't recruiting new people. That poses whole other challenges given the time constraints that we were talking about. Survey people over a broad coastal area, again, so that we can capture areas where the risks increase or decrease, given those predictability limitations. And we said that what we ideally would want to do is survey people at least 3 times as a hurricane was threatening, okay? And that we would field each survey wave for about 24 hours, have a 24-hour interval, and after we made the decision to field, it would still take another 24 hours to put the survey in the field. So based on my little mock-up there, and you can do your math, that means 6 days before the hurricane makes landfall, we're making a decision to start to do this, okay? And we also said that we would field another survey post-storm 1 or 2 weeks afterward so that we could map what people thought was gonna happen with what actually happened in their experience. I'm just gonna focus on the predictive waves today, but there's really interesting data in the post-storm survey as well. So this is what we're doing. And then another key piece from our perspective was there's so much knowledge in the risk literature, both theoretically and empirically, that we wanted to draw on that. We aren't gonna, start from scratch or reinvent the wheel. So there's a lot we know about risk information and how it theoretically shapes people's risk perceptions and how that informs their behaviors and what other factors are at play. So this is a definition of risk information that comes from the National Research Council, from a RiskCom report that they put out a while ago. It's any kind of information about the potential threat, severity, consequences, or recommended actions. So mapping that onto the weather domain, that basically means it could be a weather forecast. It could be information about what are those projected impacts. It could be recommendation, preparedness, or protective actions that are recommended, say, by your emergency manager. It could be environmental cues or social cues. We know theoretically that these are really important and they're really relevant in the weather context. And actually in the Twitter data was some of the first times that we saw how important these factors were. So we wanted to be able to measure these. So theoretically, risk information should, at least to some degree, shape your risk perception. And this is a definition. These are judgments about the events, situations, or activities that could cause bad consequences. And we make these judgments through this process of collecting and interpreting signals about these uncertain events or the uncertain negative impacts, all right? And risk perception is a huge construct, and I will show you some of the ways that we dimensionalize this. I'll talk about this in more detail in a second, but it's been studied for decades, decades and decades. There's also theoretically some awareness that your past experience with a hurricane should shape your risk perceptions. And this can be defined as your perceptions that you acquire about either the conditions or the impacts of a prior weather event. And that can be when the event is threatening or when it actually occurs. You can acquire those directly or vicariously based on something that happens to somebody else. And it can occur kind of throughout the kind of temporal timeline of the event. It can happen more than once, of course. So those are the main constructs I'm going to focus on today. So those are definitions, but here's a little bit more concretely how we operationalized them for this survey, or some of the ways that we operationalized them. So we're measuring risk information as the frequency of getting information from different sources and channels, environmental cues and social cues. We are measuring, these are some ways that we're measuring risk perception as your personal perceptions of exposure, susceptibility, severity, and worry. And I will define those, again, as we go forward. And as far as your past experience goes, one of the ways that some past work I've done has shown that it most relates to risk perception is by measuring the emotional distress or experience that people have had. So that's one of the measures, that's the one that I'm really gonna focus on today. But just so you can see that we have a lot that we can do with the survey data, these are some of the other measures. And again, they all draw from the literature. So other ways of measuring the risk information people get, a lot of other ways of measuring people's risk perceptions. So a couple of things I just wanna articulate here for everyone's awareness, that those measures I talked about before are gonna be more aggregate measures, but we can measure perceptions of risk more specifically. So maybe people's perceived exposure to different hazards, or their perceived susceptibility to different impacts. Maybe also whether they're in or out of different forecast areas. And those are all personal risk perceptions. But the literature really shows that when you ask people about their risk perception, the risk target really matters. So are you asking about what I think the risk is to me, the risk to Rich, the risk to my next door neighbor, the risk to the county next door? So we also have measures in here about people's perceived risk to the US in general, not just to them personally. There's a lot of stuff in there about efficacy. These are beliefs that people have about their ability to kind of do something or how effective those responses are going to be. And then, of course, what protective actions they took. And a lot of other variables that we know, again, from the literature that either kind of have shared variance with our kind of dependent variable of interest or that can maybe moderate those different effects. So more on past experiences, social support, normative behaviors. This all happened during COVID, so of course we had to ask about COVID. Demographics, home attributes, worldviews, and even access to basic needs, so we can start to measure some aspect of vulnerability. But I'm not talking about any of this today, just the stuff on the previous slide. So this was everything that we designed. And then in 2020, we finally had our first chance to test this out. So we fielded the survey, our first 3-wave survey for Hurricanes Laura and Marco. And these were 2 storms that were threatening the same area in the Gulf in 2020. So we ended up fielding not separately for these 2 storms, but for both of them combined. You all probably know the details about these tropical cyclones even better than I do, but just a reminder that Marco was forecast to be a Category 1 at landfall, but then weakened, and its center just passed south of the Mississippi River on August 24th as a weak tropical storm. Hurricane Laura rapidly intensified and made landfall as a Category 4 in western Louisiana on August 27th. So we made a decision on August 21st to field for these storms. And at that time, the entire Gulf Coast was, at least to some degree, at risk. And so we fielded our survey for all zip codes up to 50 miles inland from Texas all the way through the western half of Florida, okay? We did manage to get in 3 predictive waves over the course of about 5 days, and we had over 1,000 people respond to all 4 survey waves. This is what we call a balanced sample. You can actually do analysis if people maybe miss responding to a wave, but just for simplicity today, I'm going to talk just about the balanced data that we have. And I can't emphasize this enough that we had no idea if this was going to work when we did it. I mean, we really weren't sure. Were we just going to get like 20 people to respond? So we were just so thrilled that we got 1,000 people, even with losing people from wave to wave, to respond to all 4 of these survey waves for these storms. So this is what we did for Laura and Marco. And because it was successful, originally we were funded to only do this one time, but NOAA was excited about it, so they gave us more funds, and then NCAR kicked in funds. So we did this again in 2021 for Henri. And you all probably remember that at the time, Henri was forecast to be maybe the first hurricane to make landfall in New England in like 30 years. Some folks can check me on whether or not that's correct. Ultimately, it weakened right before landfall, made landfall as a tropical storm. When we made the decision to field, again, all of those areas were at risk. So we fielded in New York and all of New England, 50 miles inland, all the way up through Maine. We got 3 predictive waves in again. And one of the things that was different when we made the decision to field this time was that we actually launched wave 1 before any tropical watches went up. And that will become relevant in some of the results I'm going to show. But this was something that Josh Allen and Andrea Schumacher were really like pushing us to say, like, let's get this in the field. Let's see what happens before these tropical watches go up. So we did. And YouGov worked beautifully with us on that. Had over 800 people who responded to all of those waves. Well, we had funds to do one more round of surveys. And you might remember in 2021, there was Ida, and we made a decision not to field for Ida. And we were just kicking ourselves for a long time because we thought it was the one that got away. But ultimately, it gave us funds so that we could field one more time in 2022, which we did for Ian. And how do you even characterize Ian in 1 or 2 bullets? But you all know it intensified and ultimately made landfall. The second landfall, the first was in Cuba, the second time as a Category 4 in Florida, and then again as a Cat 1 in South Carolina. And this time we decided that we would field up to 100 miles inland because we were interested in maybe looking at some of the perceptions of kind of inland rainfall or flooding potential risks. So we fielded from Mississippi all the way to North Carolina, literally like the morning of with YouGov. We're like, drop this state, add this state. They were just fantastic working with us. We did get 3 predictive waves in, and we launched wave 1 before Ian was actually named. So again, kind of another interesting feature of this, kind of a natural experiment for us, and had over 900 people who responded to all of these survey waves. So that's what we did in terms of designing and fielding these longitudinal panel surveys. But the other key piece before I dive into the results that is so essential to this work is how we're integrating this data with the meteorological data, observations, and forecast data in multiple ways. And I just want to show you a couple of those. The results I'm going to show will pick up on just one of these pieces. But I love these plots that Andrea has generated because they show kind of the timeline of our fielding of these survey waves against both the current and forecast intensity of the storm. So basically here what you're looking at, the x-axis is hours until landfall, kind of with a longer lead time on the left. The dark gray is our histograms of the number of responses to our surveys. So you can see wave 1, wave 2, wave 3. And the solid lines, these are the current intensities of Laura and Marco. Laura's in orange, Marco's in blue. And then the dashed lines are the forecast intensity at landfall at that time when we fielded the survey. So you can see here, of course, that Marco weakened and then dissipated during wave 2. And then right before wave 3 is when Laura started to rapidly intensify, both its current intensity and its forecast intensity. So this is what it looks like for Laura and Marco. Here's what it looks like for Henri, where right before we fielded wave 3, it started to really weaken. You'll also notice here that we did not have our 24-hour interval between waves 2 and waves 3 for Henri like we had planned because its track was shifting farther west, which meant that its landfall was forecast to happen earlier and earlier as we went along. So again, just managing some of that. So that's what it looked like for Henri. And then here's what it looked like for Ian. Where you can see, again, kind of the histogram of when people were responding. We saw that this was the forecast intensity at landfall for Cuba for wave 1, and then once we got into wave 2, we had forecast intensities at landfall for the mainland US, and you really see between waves 2 and waves 3, this is when those forecast intensities really were increasing. Again, it was really intensifying quite a lot in between wave 2 and wave 3, and even during wave 3. So this offers us opportunity to take these data and look at what people's perceptions of the intensities were, but also what those actual intensities were, either to control for those variables or think about looking at them in more of a focal way. I just wanted to show this. I'm not going to talk about any of this today. Here's really how I'm going to talk about integrating the meteorological data and the results. So what we really wanted to do is be able to compare the responses of people who were in areas that had greater or lesser chance of being affected by those different tropical cyclone hazards, right? This is something that's called exposure from the field of risk. And so we worked really closely with our NOAA colleagues to kind of come up with a way of categorizing how do we decide if people are exposed to the tropical cyclone, right? And we came up with this, that either they were in the cone of uncertainty, they were under a hurricane or tropical storm watch or warning, or a surge watch or warning. They were in areas where the tropical storm force wind speed probabilities were 30% or greater, or they were under either a voluntary or a mandatory evacuation order. Didn't have to be in all of these, but at least one of them. And because we have where people, we know what zip code they live in, and we know what time they started and finished the survey, we could match them spatially and temporally to these different products. But this also gives us flexibility to consider exposure in a few different ways. So we could require all of these factors or maybe different factors, and I'll do this with Ian, so you'll see how we do this. But we also, Andrea has curated tornado and kind of flooding products as well, like excessive rainfall outlooks, QPF forecasts, even like flood or flash flood watches and warnings. So we can look at those kinds of data as well if we're interested in some of those research questions. And so, again, this is how we're categorizing people right now, just kind of in a dichotomous way, as exposed or not. And it's fun to look at what this looks like across the 3 different survey waves, right? So this is showing this for Laura and Marco, the areas that were exposed or not. So you can see on the left-hand side for wave 1, the green and blue are the cones for Marco and Laura during that 24-hour period that we fielded that survey. The red are the hurricane and tropical storm watches and warnings. Orange are storm surge watches and warnings. Purple are the tropical storm force wind speed probabilities. And then colored in yellow are the zip codes that are considered exposed, and in black are the ones that aren't. And remember here, this is also based on what time people responded, okay? So you can see that the area that's exposed at wave 1 is pretty big. It gets smaller at wave 2 and gets even smaller at wave 3, all right? And these exposure versus not categories are going to come into the results, so keep that in mind. What was interesting is for Henri, the same categorization didn't yield much in the way of not exposed based on kind of the track and its orientation to the coast. So you can see at wave 1, we only had 14 people who weren't exposed based on this definition. Nobody at wave 2, just a handful of people at wave 3. So again, kind of suggesting that maybe we would want to consider exposure in maybe more refined ways, in ways that would map our research questions. And then here's what it looked like for Ian. And in Ian, actually, we had the number of people who were exposed increase from wave 1 to wave 2 to wave 3, based again, like on the track relative to the different population centers. Okay, so this has built up the entire methodology. Now we're going to get to the good stuff, make sure I have time to cover it all. It's really starting to dig into the results. So I've hopefully made the case that this really is a novel methodology where we've collected this data, integrated it with meteorological data. And I don't even think I'm overstating this when I say that this right now is unparalleled. To our knowledge, nobody else has done this, and it has a lot of power and flexibility for analysis. And this is really what I want to show with some of these results. So now we're going to dig into, remember, I was talking about those two big constructs, risk information and risk perception. Well, here's what I mean by risk information and these ways that we measured it. So we measured the frequency of getting information by asking people at each wave, during the last 24 hours, how often did you get information about the name of the storm from each of these sources listed below? We asked about your local broadcast meteorologist or local news. Public officials was another one. We actually asked about others. I'm not going to focus on them. We also asked about looking outside at the weather. This is a measure of those environmental cues. And then we did something similar to basically measure people getting information via social cues. So during the last 24 hours, how often did you see other people doing these things, preparing their home or getting emergency supplies? Because again, we know this is really important for shaping people's risk perceptions. Okay, so what I'm going to show here, these are just the results for one of those sources. I'm just showing the mean frequency of getting information, and this is just for Laura and Marco. And then the plot on the left-hand side, I'm showing this for the full sample, but on the right-hand side, I've broken it up into those exposed versus not, based on that categorization I talked about. And on that y-axis, this is the mean number of times in the last 24 hours. The x-axis are those 3 different waves. So it's the mean at wave 1, 2, and 3. And if you look at the full sample, you realize kind of that it's kind of underwhelming, right? Like you don't really, get some interesting detail. But really starting to break out that exposed versus not exposed is where we can see that, oh, it's the people who are in those exposed areas that are really similar to the not exposed areas at wave 1 in terms of how frequently they're getting information. But as you go to wave 2 and wave 3, you start to get this fanning out. So the people who are exposed are getting information maybe a little bit more, and especially by wave 3, and the people who aren't exposed are really decreasing the amount of information on average that they're getting. Nothing that's really like revelatory, but just something that we've never captured before with these with things that we might have imagined but have not been able to see before. So this is for Laura and Marco. This is what it looks like for Henri. Again, this is still just focusing on those broadcast meteorologists or local news. You notice here that the full sample and the TC exposed are nearly identical, and that's just because, remember, you had very few people who weren't exposed in Henri. But what's also interesting here is if you look at wave 1, people are getting information less frequently. And remember, again, that we fielded this wave before those watches went into effect. So we don't know for sure if kind of this lower mean frequency is due to that, but I think it's a pretty reasonable kind of hypothesis to think that that's what was going on. And then again, those people who are TC exposed are getting information a little bit more frequently at wave 2 and then at wave 3. And here's what it looked like for Ian. And I don't know about you, but when I first saw this plot, especially of the exposed versus not, I was surprised. I thought it was a lot less than what I would have thought, given the intensity of Ian, especially for those people who are TC exposed. You got some bump between wave 2 and wave 3, but maybe still overall, these means are lower than I would have imagined. But remember how big the area of the people who are TC exposed encompasses, right? So this is where we do have flexibility in how we can look at exposure. And so one of the things we wanted to do is, because we actually had, this is a good thing for data collection, a bad thing for society, that you had a pretty big population of people who were affected by a major hurricane. We had enough of a sample size in these really refined areas. And so what we did is we looked at just West Florida and just people who ultimately ended up in a storm surge watch or warning area. And we're coloring that now our red exposed group. So it's kind of like your highest level of exposure or highest risk exposure. Orange is everything else in the way that we had defined it before, but also in a way that's mutually exclusive. And then in blue are the people who aren't exposed. Okay, so now we have 3 levels of exposure. So let's go back and look at that again. And now you start to see maybe more interesting differences. So if you look here at that red, again, West Florida storm surge watch warning area. Interestingly, even at wave 1, they were already getting information more frequently. It was pretty consistent from wave 1 to wave 2, but then really jumped between wave 2 and wave 3. So you can start to differentiate these different exposure areas and see how people are behaving in them. So this is for Ian, but it's also nice to be able to look at these across storms, right? And even if we can't statistically compare across storms right now, we can eventually just start to qualitatively eyeball and look to see if there are similarities or differences. And so one thing I noticed here with Laura and Marco is that overall, with Laura, people started off higher, especially in that exposed category in terms of how frequently they were getting information from their local TV meteorologist or local news station compared to Henri, and even compared to the people who were exposed in Ian, except for those people who are in that most exposed West Florida storm surge watch warning area. So you can start to look at these, like I said, across storms. So now I'm going to throw 15 plots at you, because why not? So we've got all 3 storms here in rows, and now we've got all of those 5 sources or ways of getting information. Okay, and I know that there's a lot here, but at least 3 or 4 things that I pull out. So first of all, people are getting a lot of information. Overall, if you pick a storm and look across these different sources, they are collecting a lot of information. Local news, in particular at wave 1, still reigns supreme. This has been in the literature for a long time. But we do see people are getting information in other ways, and especially when you get to those later waves, public officials, environmental cues, and those social cues do start to become really important. Another thing that I really see here is that compared to Laura and Marco, with Henri, we are seeing, again, with local news, that there's this kind of lower amount at wave 1, maybe also for public officials, but they are starting to really increase by the time you get to waves 2 and waves 3. You also see that overall, the people who are exposed are getting information in general more than the people who aren't. But what's interesting is the people who aren't exposed aren't dropping off that much. Like, they're still paying attention, they're still attending to this, other than maybe the people who are relying on environmental cues, and that makes sense, right? They don't have environmental cues to rely on, so they're looking at that less. And then we also just see with Ian that there was this big bump in how much information they were getting really between waves 2 and waves 3, okay? So this is one way that we can start to look at the risk information. I'll show another in a second, but I want to first move on to people's risk perceptions. And when I said that we measured this kind of personally and in aggregate, here's specifically what I mean. So the first measure, and again, this all comes from the literature, is how likely do you think it is that the area where you live will be affected? This is what we call perceived exposure. If the area that you live is affected, how likely is it that you're going to experience negative impacts? This is perceived susceptibility. If you are to experience negative impacts, how likely or how severe do you think those will be? This is perceived severity. This is what we call in the risk perception literature kind of cognitive measures of risk perception. But then there's also kind of this emotional or affective component. How worried are you going to be about the storm affecting you? So what we specifically call a form of negative affect. So now I'm just going to go straight to, here in this case, just 12 plots so that we can look at this across Laura, Marco, Henri, and Ian. And in those columns that we go exposure, susceptibility, severity, and negative affect or worry. And this is where we can also really see differences across storms, right? So in Laura and Marco, for those people who are exposed in particular, that orange line, they start high and they stay high across all of those different risk perception measures. Here, though, is where we, again, see that bump from Henri. Really low, not really low, lower risk perception at wave 1, but it really does increase by wave 2, and then maybe drops off a little by wave 3 when people realize that it's probably just going to be a tropical storm. And when you look at Ian, really looking at those red and blue lines, you start to see this fanning out pattern that for Ian, again, between wave 2 and 3, there's risk perceptions are really increasing for those people in West Florida, the storm surge watch warning area. And then those people who aren't exposed, their risk perceptions are really decreasing, again, especially between waves 2 and waves 3. So these are just some descriptive ways we can look at the data. I'll check my time here. I'll try to go through this quickly, but this is also more complex, so I want to make sure everybody comes along. So we can start to move beyond this and do more statistical modeling of the data that we have, more specifically with what's called multi-level modeling. And I'm going to talk about growth modeling, and in particular linear growth modeling, which does allow us to start to look again at whether, when, and how people are changing and who is changing. And it lets us examine differences within people as they're changing over time, but also differences between people given factors that aren't changing between people, at least on the time scale at which we're collecting data. So these are more time invariant variables. And then, of course, we can also control for other things that we know, again, might be related to our outcome of interest. And when we're thinking about doing this kind of modeling, there's sort of basics of investigating change over time, and methodologically kind of 3 features that are really essential. You do need 3 or more waves of data, because if you just have 2 points, how do you know whether it's a trend or not? A reasonable way that we can measure time, and in this case, we're using waves. We can actually measure that more granularly, but right now, I'm just gonna do it in terms of wave. And then you do need an outcome that you think reasonably should be changing over time. And just to connect this back, remember that we're interested in looking at whether and how the risk information people are getting and their risk perceptions are changing due to these changing hurricane risks. So we would hypothesize that these would change over time, right? Okay. So just to briefly introduce you to some basics of what we call multi-level modeling. This is what is the level 1 model. It is called the individual growth model, okay? It describes how an individual changes over time or what their change trajectory is. Looks pretty straightforward, like a simple linear regression, right? Where that first pi parameter, that pi sub 0 I, is the person's initial status, right? Like that's where they're starting when we start measuring them. That pi sub 1 I is their rate of change over time. So again, just their slope. So pretty straightforward. Here, time is just the parameter that represents time. For us, it will be wave. And this is the level at which, if we do want to add time-varying predictors, that we would do this at. And that will become relevant here in just a second. The level 2 model, then, is what lets us really look at differences between people. So it describes that between person difference in change, there's change trajectories and other predictors that we might be interested in looking at, but ones that are called time invariant. And for now, I'm just gonna have one variable there called X, okay? And one thing to notice is that the outcomes here, the dependent variables here, are the growth parameters from this model. So this is what we're actually trying to model in the level 2 models. So this is where, for me, I start to do a little bit of the mental gymnastics. So that first level 2 model is really just focused on the relationship between the intercept and our predictor of interest, okay? And more specifically, that gamma 0, 0, so now we're looking across our sample, across the population. That's the average intercept when our predictor equals 0. And then that gamma 0, 1 is the shift in that intercept, either up or down, when there's a 1 unit change in that predictor, okay? So this first level 2 submodel is all about the intercept. And then the second level 2 model is analogous, but it's all about the slope, okay? So that gamma 1, 0 is the population average slope when our predictor is 0. And then gamma 1, 1 is the shift in the slope when our predictor changes by 1 unit, okay? So this is kind of in general, but I think it's helpful to think about this more concretely. So imagine we are interested in predicting, well, we will be interested in this because I'll show this, in predicting changes in risk perception over time, whether there are differences due to whether or not people have past hurricane experience, okay? So we can have these kind of generic models, and this is what it looks like more concretely. So you can see that really we're interested in ultimately predicting risk perception, and our kind of time invariant predictor of interest is their experience, their past emotional experience coming into the hurricane. Of course, it's going to change during the hurricane, but we measured this at time 1. And just to kind of flesh this out a little bit more so that you can see more fully here. So again, when we're looking at those individual growth parameters from that level 1 model, that first pi parameter is the person's initial risk perception. The second pi parameter is how that risk perception is changing over time. And then with those level 2 models, we're looking at the relationship. That first one is the relationship between the intercept of people's risk perception and that predictor, which here we're focusing more concretely on experience. That gamma 0, 0 is that initial population average intercept for people who don't have past experience. And for people who do have past experience, the other gamma parameter is the shift in their intercept, their initial risk perception. And then again, analogously for the slope. So that second model is modeling the relationship between risk perception, the slope of people's risk perception and experience. That gamma 1, 0 is the average slope for the people who don't have experience. And then that gamma 1, 1 is this shift in the slope for the people who do. And just for simplicity here, I'm showing this with our parameter X or the experience as a dichotomous parameter, but it doesn't have to be. It can be continuous, of course, because you can have more than just one unit shift for those continuous variables. Okay, so I will have time, fortunately, to show the interesting results from our data, but just a final thing here is that together these are what we call the multi-level models, and it does kind of let us reframe these maybe general questions with things that are more specific so that we can investigate, like, how are people differing in their initial status or in their rate of change over time, and how are those time invariant or time varying predictors playing a role, okay? So just to wrap things up with a couple of research questions and a couple of results, these are two that I want to talk about. So the first one here is, how are people's risk perceptions changing over time based on their different levels of exposure? So remember, that's what we categorized before. This is time varying because it does change over time, and whether or not they have this past emotional hurricane experience, which is time invariant. But the second research question is really, what is the sweet spot of being able to do this multi-level modeling with our data set and what our data set offers? Because we can have 2 time-varying variables in here or more. So how are people's risk perceptions changing based on their different levels of exposure, again, but also based on the different amount of risk information that they've gotten in the past 24 hours, which again is time varying, because you remember those descriptive plots I showed. It was maybe lower at wave 1, but then increased at wave 2. So how is all of that changing the risk perceptions? And because I don't want to subject you to like a set of another 15 plots, I'm going to simplify this here. So instead of looking at all of those 4 measures of risk perception individually, here I've just collapsed them into a summed index, which is also valid from the literature perspective. So now it's the summed index of those 4 measures: exposure, susceptibility, severity, and worry, measured on a 1 to 5 scale. So it's going to go from 4 to 20. And then with these independent variables, we have this time-varying exposure, again, and here I'm going to focus on results from Ian. So we have those 3 different levels: that West Florida storm surge watch warning, everybody else who was exposed, and people who weren't. The time invariant predictor of people's past emotional experience, which we just measured dichotomously, whether or not they said they have emotional experience due to a hurricane, or have experienced emotional distress due to a hurricane. And then that other time-varying variable is that risk information that people were getting. And here again, for simplicity, I took those 5 sources or ways that I talked about before, and I just collapsed them into a summed index. So this is now the frequency of people getting information 0 to 6 times each across these 5 sources, or aggregated among these 5 sources, okay? So here's that first research question. How do their risk perceptions change over time based on different levels of exposure and whether or not they have past emotional experience? And so in this plot, the colors are the same as what you saw before. That's representing those different exposure levels. Here, the dashed lines are the people who said, yes, I have experienced emotional distress due to a hurricane, and the solid lines are people who said, no, I haven't. And what you can see is that there are different patterns for these different categories of people. So a couple things to pull out is that, so for each of those exposure categories, so for the red, orange, and blue sets, the people who have past emotional experience have a higher initial risk perception at wave 1. So it's just that delta between the dashed and the solid lines for each of those exposure categories, right? Interestingly, though, at least this was interesting to me, for the 2 exposed groups, so the red and orange sets of lines, the people who do have past emotional experience, they don't really increase their risk perception any faster than people who don't have it. The slopes more or less are equivalent. They're not statistically different. So they start higher, but they're not really changing at any faster of a rate than people who don't have past experience. But for the people who aren't exposed, those blue lines, the people with past emotional experience are decreasing their risk perception faster than people who don't have it. And we don't really know why, like what those mechanisms are, but you can imagine that people who have past experience and maybe have kind of concern or they have higher perceived risk are happier, maybe. They're kind of like experience some sense of relief, and so the risk perception is actually decreasing faster when they realize that they're not actually at risk. So kind of overall, initially past emotional experience does play a big role kind of at wave 1, but then when it comes to people's risk perceptions, it's really their exposure levels that are doing the heavier lifting kind of overall in general, okay? So now let's look at the last set of results here, and this is again where we have 2 time-varying variables. How do their risk perceptions change over time, again, based on those different levels of exposure and based on the amount of risk information they've gotten in the past 24 hours. So here, again, the colors are the same, but the dashed versus solid lines represent kind of the same idea, but the dashed lines is the max frequency of getting information across these 5 different sources, and the solid lines is the minimum frequency from which people got information from these 5 sources. And there are a few interesting patterns that come out here too. So first of all, for each of those exposure categories, the people who have gotten the maximum amount of information have initially higher risk perception, right? It doesn't even matter what their exposure level is. Their risk perception is higher based on, for those folks, again, who have gotten the most amount of information from those 5 different sources. You do see a similar pattern, kind of if you look at the pattern of like the dashed lines and the pattern of the solid lines, there's a pretty similar pattern there overall in the people who've gotten the max information versus the ones who've gotten the minimum amount of information. But what's interesting is, let's just kind of ignore those 4 lines in the middle. There's not really that much interesting going on here. The interesting stuff are those extremes, okay? So that dashed red line, those are the West Florida Storm Surge Watch Warning exposed people who've gotten the maximum amount of information over time. Their risk perceptions are actually increasing over time. That's really where we see a significantly different slope. And then that bottom line, that blue solid line, the people who aren't exposed and who say they're not getting information, although it's a little bit questionable whether they're actually not getting information because their risk perception is decreasing over time. But remember, these are just like 5 ways of getting information. We measured other things. But for those people, their risk perception is actually decreasing. So overall, we see that the biggest effect here is the frequency of information that people are getting at wave 1. But overall, there's still not much of a big effect of how much information they're getting on their risk perceptions over time, okay? But this analysis is really what lets us start to investigate these questions. And so just to wrap up, because I do want to make sure we have time for questions, I mean, for those of us who are working on this project, we feel like we have so much data, but when you kind of situate this in the context of all the meteorological data that we have available, this is really just a drop in the bucket. And so what we really feel like is we need to be able to scale this and collect data over more hurricanes. And we have been talking a little bit about, are there ways that we can get more diverse samples or target maybe particularly vulnerable populations? But then I also would love to extend this to other weather hazards. And maybe it's easiest to do this kind of for these longer fused hazards that cover kind of larger aerial extent, like winter storms and heat waves. But I'd really love to do this for fire weather or for tornadoes or other severe weather in the future. And then we have been already starting to have conversations with NOAA about, kind of like we do in meteorology. We start to collect observations, we understand, then we understand processes, and then we predict. And then we forecast. Can we operationalize this knowledge? Can we think about gathering these data in real time and analyzing it in near real time so that we can identify, are there critical misperceptions among people, or people who aren't aware who should be? And are there ways of kind of intervening in some way that we might operationalize risk communication or incident risk communication? And then I think last but not least, this to me are the kinds of things that National Center like NCAR should be doing, is establishing this kind of data set for the community to work with. So that's not just ours, but making this data available out there for researchers and practitioners who want to contribute and utilize these data in ways that we haven't even thought about. So I'm gonna pause and thank you all and hope that you'll have questions and ideas. So, thanks. Oh.
Paper's open for questions.
Great talk, Julie. I love the analysis, wondering about the multi-level modeling. I'm assuming that all of those models are, that you're going through some sort of statistical significance. And even though you started, I could imagine 2 ways of approaching it, right? You could have a research question, which seems like these 2 you did because you've worked in past experience before. Are you going kind of in both directions where one, you come up with research questions and look at the predictors, and then are you just running everything and seeing what comes out as statistically significant? And if so, like, has anything surprised you, or was there anything fun or different that you found from that?
Yeah, good question. So yes, there are ways of evaluating the significance, both for all those parameters, but also as you're building models so that you can see like differences, like model building in general. I just decided not to show that. I could have put the actual kind of values of those parameters, but it's just more interesting to look at the plots. Right now, we're starting with what kinds of questions are we interested in, because there's so many things you could run that I worry if we kind of start going down that path too soon of just like more exploratory, that we might not be able to make sense of any of the results. And I think we just wanted to start first with like, what are the reasonable things that we might hypothesize or expect? And then I think eventually we might open it up. I will say, our collaborators at Stanford, they come from much more of a psych judgment and decision-making background where they pre-register their analyses so that they aren't even looking at the data until they have hypothesized or articulated their research questions and exactly what variables they're going to look at. And then they're adhering to that, building in a little bit of opportunity to do some exploratory analysis, but just so that there aren't issues with p-hacking or, just kind of searching for results that maybe are significantly, statistically significant, but aren't meaningfully significant. So they kind of have a different approach from even how we're doing it, but it's been fun to learn from each other. Good question. I think, Jimmy.
I'm interested in YouGov. Who are these people and what are they signed up for and what else do they use that site for? And is there any reason to go anywhere else? Because it looked like it worked pretty well.
Yeah, good question. So, there's like 3 ways I can answer this question. So YouGov is, it's a nonprofit company worldwide that does these kinds of surveys. They recruit from a lot of different modes and mechanisms and venues, and they actually field surveys. People will do surveys about a lot of different topics. In fact, when we were doing the 2020 survey, they were clear. They're like, you need to get your survey in the field by the end of September because it's election year, and we're not going to have time to manage this if you start getting into October. So we do have demographics of, actually, I didn't put the demographics in here for Ian, but you can see the demographics of our sample, so you can see who they are, at least in our sample. I didn't compare this against the entire demographics of the YouGov sample, but one of the things that we really want to do is actually, and we just proposed this to NOAA, is come up with our own ways of augmenting the sample, especially if we're trying to reach maybe more vulnerable populations, because we know we're getting an older, retired, Caucasian, well-educated group of people, and we want to be able to try to diversify beyond that. So, good question. Yeah, Sue.
Okay, 2 questions really. One is, you found that the more information people had, the higher their risk perception. Couldn't you interpret that the opposite way, that the more risk perception, the more they're going to look for information?
Yeah. So it's funny, Chris and I were just talking about this because based on his longitudinal work, we were talking about how we have all these complex questions of causality, and you hope that these data are going to start to illustrate things that make sense, but you start kind of almost like, winding yourself into a bit of a kind of intellectual quagmire. And yes, it is possible that as people's risk perceptions go up, their information seeking goes up, right? So you can start to do cross-lagged analyses too across the different waves of data to see if that's what's going on as well, or looking at the effect of risk perception on risk information seeking as your dependent variable. So you can definitely have causality in both directions, and that's something that we intend to explore.
Okay, interesting.
Yeah.
And the other question is, you looked at risk perception, but how does that correlate with smart decision making?
Yeah, good question. So we haven't analyzed the data with the protective actions people have taken. That's actually a different, analogous but different set of analyses. It's called event occurrence. So you kind of have this binary yes or no. Are they engaging in different protective actions? I will say, so we have the data on the protective actions people have taken, but we haven't gotten into the full kind of multi-level modeling analysis for that yet. But for every one of those waves, just FYI, we measured whether or not people were evacuating, whether or not they were engaging in different ways of protecting their home, if they were gassing up their car. So actually like a range of different protective behaviors from like the ones that require the most amount of effort to like the lower effort ones. And like I said, we have the data descriptively, but we haven't actually done the analysis yet with the multi-level modeling. It's something we intend to do next.
Further questions?
So how does YouGov exactly field those surveys? Do they email them to people? Okay, so and then what's about the percentage of returns you get?
So it's a really good question. It's hard for us to actually measure true response rates because they are kind of, especially for the first storm that we did for Laura and Marco, I think before we even, I'm going to back up. and this also responds to Jimmy's question in some way too, before we ever even wrote the proposal, we worked with a lot of different survey companies because we needed to know what their feasibility was. Like how many people were on their panel, how many people were on their panel up to 50 miles inland across all of these states. So we have those data. But when they fielded the first survey, I think they were just like blasting as many people as possible in those areas. And then we closed things down, of course, after 24 hours. So we don't have the data on the response rates at that point. And we haven't even gotten the response rates from them for Henri and for Ian. But I don't think that they're making decisions to send it out to even fewer people because, again, we're just trying to get as many people as possible to respond to these, given the very short fielding period. But so you can imagine, of course, like in Texas, areas like with Houston, like they have a lot more people on their panel there, but when you get, this is one of the challenges we had with where Laura made landfall is it's a low population area and there's just not that many people on their panel. So the people that were at highest risk from where it ultimately made landfall, we just don't have a really big sample of people there compared to in Florida. But yeah, they are sending out emails and then actually reminding people throughout the day.
All right, thanks.
Yep. I think Rosie had a question.
Look this way.
Rosie.
So my parents in Puerto Rico won't put up shutters unless it's a Category 1 hurricane. It doesn't matter if it's a 72 mile per hour storm.
Mm-hmm.
Do you have any data that could tell you the perceived exposure or risk depending on the categories?
Yeah, so we actually asked, what do you think? We have data on what they think the current intensity is, and then also what do they think the intensity is going to be at landfall. And we actually have done comparisons to be against like what they think it was currently versus what it actually was, and also what did they think it was going to be at landfall and what it actually was. So those are data that we can, kind of to Sue's point, look at in conjunction with what protective actions they're engaging in to see if that is explaining. That would be one of the first logical research questions to investigate because we hear that a lot, that the category level is what really drives a lot of decision making. So we can look at that.
Yeah, and then there's people who want to get rid of the scale altogether.
Yeah.
I have a question. How much of the sort of dependencies are sort of a basic feature of human psychology, and how much are really based on? I mean, for example, like in a war zone, people closer to the eastern Ukraine, for example, and western. If you had the same kind of survey, I would imagine the same kind of spread in the curves. So
you're asking about like how much does it depend on the risk or hazard type is what you're asking?
But those slopes in the curve,
Yeah.
wouldn't they?
So I would say it's an empirical question. We don't really know. It's interesting because we presented some of this research at the Society for Risk Analysis. One of the people that Chris has worked with in the past, Brandon Johnson, basically followed up with us, and he's like, we want to do the same kind of stuff and submit a proposal and have it be across a bunch of different types of risks so that we can see if there are kind of just these common patterns that are based on kind of human ways of being or how much it is dependent on the risk itself. But until we can field almost an identical instrument for sets of different kinds of risks, it's hard to tell. It's a good question, though.
Okay.
Yeah.
Well, thank you. Okay. Well, we invite you all to have some coffee and further interrogations of the speaker.
Interrogations. Thank you.